Now you can start, Maria. The recording
Okay.
is ongoing.
Okay, thank you. So good morning, everyone. I'm sorry that we start a few minutes later, but thank you so much for your availability and to be here today. To start, I'm just going to present the agenda that we have prepared for today for this webinar called the Water-Energy Nexus Approach, Rethinking Efficiency. So our goal here is to present the work that has been done inside of the meetMED 2 project, but the activity, the Water-Energy Nexus. And for this, initially, we were going to have Agatha Lancôme, the work package leader, to present the opening remarks, but she will not be able to be here today. So we are going to start with Rita Pestana, my colleague from ADENE, from Portuguese Energy Agency, and she's going to present the Water-Energy Nexus methodology. This was the metrics that we developed with inside this activity. And after this, we're going to have Mohamed Mosleh from NERC, from the Jordan Energy Agency, and also Fairuz Hamli from Algeria Energy Agency. And they are going to present a case study. So they have been in these last few years, they have been applying this methodology to pilot buildings selected in their countries, and they are going to present their experience and what were the main challenges and opportunities with this methodology. After that, we will have a time for the questions and answers. Of course, during the webinar, you can put your questions in the chat. So if you prefer to put the questions, and then we will answer in the end of the webinar. And for the closing remarks, we're going to have Charles Buttigieg from EWA, because we have been collaborating. It's Malta Energy and Water Agency. We have been collaborating with them in this activity, so he's going to present the closing remarks. So to not be more delay, I hope everyone can enjoy this session and learn a lot about this theme. And now I'm going to give the floor to my colleague, Rita Pestana. Thank you, everyone.
Good afternoon, everyone, and thank you very much for joining us. I will just I'm just going to share my screen, so just a second. Could you please confirm if you're
Yes.
seeing the presentation?
Yes, we
Yeah.
can see the presentation. Go ahead. Best of luck.
Thank you so much. So this webinar is about the methodology called the Water-Energy Nexus Evaluation Methodology for the Mediterranean Basin. And this methodology was developed within activity 313 of phase 2 of the meetMED project. So I just would like to start with a short contextualization of where does this come from, this methodology comes from. So for that, I will speak a little bit about the Water-Energy Nexus. So according to the Water-Energy Nexus, the water and energy are two resources that are interdependent and that have mutual impacts on each other. What does this mean? That the two sectors, the water sector and the energy sector, therefore depend on each other. So how does this work? On one hand, as you can see on the left part of the screen, water is a critical factor for the production of energy. And this includes what? Includes, for example, the production of electricity through hydroelectric power production. It includes production and distillation of biofuels. It includes fossil fuel extraction, includes transformation in plants and refineries, including the cooling down processes that take place in that. And just to let you know that actually the energy industry in general, all around the world, is responsible for about 10% of the total fresh water consumption worldwide. So on one hand, we have water as a critical factor for energy, and on the other, we have energy as a critical factor for the water cycle. And in which points, in which processes? So energy is necessary for the production or abstraction of water, water treatment, transportation, and distribution, and also use. So, but not only that, it's also necessary for the collection of wastewater and for the treatment of the wastewater. And as well, it is necessary for example, the production of water through desalination. So, according to the International Energy Agency, actually the water sector is currently responsible for around 4% of all the world's electricity production. What does this mean? It means that if we have water scarcity, by one hand, we can have limitations on energy production. On the other hand, if we have limitations on the energy we have at our disposal, we'll also have limitations on the water production, distribution, and use. So if we look now at the global situation related with the water-energy nexus, what we have the fact that we actually have numerous factors that affect the quality, the quantity, and the variability over space and over time of the water that we have available. Due to what? We have the effects of climate change, and in here we include not only the increase in global average temperature, but also the modification of precipitation patterns all around the globe, and as well the increase in the frequency, intensity, and impact of extreme weather events. And in here we include the droughts, floods, or for example, the heat waves. Another factor that affects water is the increased consumption and competition for water. So on one hand, we have growing population, increasingly growing population. We have new economies, new sectors developing. And on the other hand, we have also migration, internal migration to urban centers. So the geographical patterns of water demand are actually currently changing. The third big factor that affects water availability is the increase in pollution. So we know that according to UN Water, only around 60% of water bodies assessed in 89 countries in 2010 actually had good water with good quality. And on the other hand, around 40% of all domestic wastewater around the globe is actually not treated properly and thrown directly into water bodies. On the other hand, as well, we have the industry and agricultural the industry and the agricultural sectors as major water polluters. What does this all cause? We actually increasingly seeing an imbalance between the human needs for water and the water that is actually available. Therefore, an increased pressure worldwide on the water resources. And remembering what we just saw in the previous slide, this does not affect only the water sector, but it affects as well the energy production and the energy availability. If we look more specifically in the Mediterranean Basin, the Mediterranean Basin is already a region that presents water scarcity at the moment. So I'm talking in general about the region, not specifically in any country. So usually we have long summers, which often have long droughts episodes, but that then alternate with autumns or winters that have intense rainfall. And we have as well areas where groundwater depletion is already a factor. And we have as well rivers that have already low flow problems. This adding to all the climate change effects we just talked, to population growth, to a growing economic demand for water, and therefore a growing competition for water between different sectors, and the fact that the Mediterranean countries still strongly rely a lot on fossil fuels. So taking into this context, we understood as very interesting and useful to develop a methodology that would actually act on the water-energy nexus at the buildings level for the Mediterranean Basin. So this methodology is named the Water-Energy Nexus Evaluation Methodology for the Mediterranean Basin, a long name. And it was developed by ADENE, the Portuguese Energy Agency, on the scope of meetMED 2. So the aim is to assess and promote the adoption of measures that reduce the energy and the water consumption, and on the scope of this water-energy nexus and on the dependency between these two factors, while enhancing the resilience to climate change on the Mediterranean buildings. So what we look in this methodology are actually three dimensions. We look at the water efficiency dimension, at the water energy nexus dimension, and at the local climate adaptation dimension. And when we look at the local climate adaptation dimension, we look specifically at climate risks that actually affect the good production, abstraction, distribution, and use of water. So we're talking about here on droughts, on floods, coastal floods or riverine floods, and heat waves. Okay, to give an idea how the methodology actually works, so we start with the three big dimensions. So the water efficiency dimension, the water energy nexus dimension, and the climate adaptation dimension. And within each dimension, we have several areas of evaluation. So big areas of evaluation. Then we go into smaller themes within each area, and then within the themes to the specific criteria that are actually the questions, the specific question we need to answer in order to apply the methodology. So this is a cascade type of methodology evaluation. We go deeper into the details, and the methodology is supported always by documental proofs and in situ measurements. By documental proofs, we mean technical documentation, energy tax, proofs of purchase of all the equipments or fixtures or systems that are related with the production, distribution, and the uses of water within the building. And in situ measurements always happen when the methodology is applied to a building that is in use, is constructed, and it can be measurements, it could be photographs that you take of certain features of the equipment. So we always need documental proofs and measurements to actually apply the methodology. Going a little bit into detail in what we actually evaluate in the water energy nexus methodology, we're looking now at the water efficiency dimension. So in bold, in the beginning of, on top of the slide, you see the big area. So we actually look at the water sources and networks. We look at other uses that can include outside uses. So in here, you look at the themes irrigation and swimming pools. You look at the fixtures, the efficiency of the several fixtures that may exist in the building. These include different types of taps, sink taps, bidet taps, service taps, kitchen taps, as well as showers and toilet flushers. So in here are the themes within this big area. We look as well to washing machines, laundering machine and dishwasher, and to the monitoring of water. Taking a look now at the water energy nexus dimension, it has a similar structure in terms of areas. So we have similar equivalent areas for the water energy nexus. But in here, we are looking at, we're trying to assess the energy that is related to the water uses. So, for example, in water sources and networks, we're actually looking at pumps that help for the circulation, distribution, and use of water. And for example, also as well for how do you, if there are renewable sources of water, alternative sources of water, how do you supply it? So it's using an electric pump. Is it using gravity? So you just you have a system that actually allows your water to flow, and you use it without spending energy. So we look at this type of points. The same for irrigation. We're actually looking at electric or not existing pumps that are used for irrigation. If existing for a swimming pool, we look at energy and maintenance and at specific parameters related with indoor swimming pools. Fixtures, concerning fixtures, we look at the pressure and head loss of the network of the building. Washing machines, again, looking at energy efficiency of the equipment. If there is hot water, so we analyze domestic hot water network concerning insulation of the pipes, energy and maintenance, and the existence of other equipment that is relevant for the use of hot water. And similarly to the water monitoring, we also analyze how the energy monitoring is taking place, if there is some type of energy monitoring in the building. Now a different dimension, the climate adaptation dimension. This has a different structure relating with the areas. So in here, we look at local strategy and policies, and specifically to the existence and the characteristics of the local climate adaptation plans in the area where the building is built. We look at the project area. So in here we assess climate risk mapping and how does how is the supply of fresh water to the building. Usually we're talking here about the public distribution of water. And finally, at the area project response, where we look at different measures that mitigate the climate risks that are relevant for the area where the building is built. The water fit for purpose. Okay, so consider here if you're using the ratio, you're using water that is potable for non-potable uses, and planted areas. Okay, so So in total, we are evaluating within all these three dimensions a total of 66 criteria, so 66 questions. It includes what? If we'll take a look, we are talking about inside and outside water uses. We're talking about all water sources and networks. We're looking at fixtures and their efficiency in terms of water and in terms of energy. We're looking at domestic hot water networks, if they exist. We look at water and energy monitoring. We're looking at the local climate adaptation plans, if they exist or not, the mapping of the climate risks that are relevant for the project area, and the mitigation measures that are actually implemented in the building. So in general, that's what we look when we are applying this methodology. So this methodology is applicable to residential, small service and commercial buildings in the Mediterranean Basin, and it can be applied to their different life cycle stages. So we can apply them on the design phase, or on a constructed building, so new constructed, already constructed, or in operation or in rehabilitation. And concerning the scale, we actually look not only to buildings, so a complete building, but we're looking also at dwellings. So we can either evaluate a building can also evaluate only an apartment, for example. So when we apply the methodology, we'll have scores and classifications at the end. And these scores and the classifications reflect the efficiency of the building on the 3 dimensions, and also a global efficiency, let's say, classification. So how does it work? We have the 66 questions, so we answer all these questions, and each question has a weight and will give you some score that's added to the total score of the dimension. So this is a value between each dimension will have a value between 0 and 100. That is actually also translated, according to this graphic, into a classification that goes from the F, least efficient, to A+, the most efficient. So this already known type of efficiency scale. So the higher the score, the higher the efficiency in each of the dimensions, and also the global score. So this means each building will have 3 sub-classifications, 1 for each dimension and 1 global classification. How to apply the methodology? We actually have 7 steps. These ones in here. So first you need to select a building according to the factors I mentioned before. So a residential building or a commercial small service building. Then the second step is to gather documental information regarding the building and all the water uses, distribution, abstraction, production, in case there's some local source of water. And also always analyzing because the methodology is on an Excel workbook, so it's a matrix on an Excel workbook. So you look at all the questions, and then you try to, before going to the building, gather all the documental information that will actually help you fill the Excel file. Then if the building is constructed, if it's a new construction or a building in use, you perform the in situ technical visit. And with all this information, you fill in the evaluation matrix. After filling in the evaluation matrix for the current situation of the building, you actually go and select improvement measures. You can select for all 3 dimensions, the improvement measures for the different dimensions of the methodology, which it means they act on improve the efficiency of each of the dimensions, and you reapply the methodology in order to have the results after the selection of the improvement measures. Then you ideally implement the improvement measures on the building. So the equipment, the systems you decided to implement. This could be, for example, introducing a solar thermal system for having hot water. It can be changing fixtures, so the taps per more efficient fixtures with lower flow. It can be many things. And then after implementation, you monitor water and energy consumptions and other indicators you may have defined as important to monitor if the actual implementation, the measures you implemented are actually having results. Just a note on the in situ technical visit. This is the equipment that we usually recommend for the in situ assessment. So it's important to always document all equipment, all water uses, for example, tags as well from the equipment, technical tags, etc. So it's important to have a camera, a photographic camera, or a mobile phone. Today, you can actually do almost everything with a mobile phone. You would also need a flow meter or standard volume to actually do measurements, perform the measurements of water flow in taps and in showers. So this in here on the right in red, you see a flow meter, but it can actually, this type of measurements can actually be done with a regular volume from the kitchen to measure flour or measure milk, water, etc. So if you actually open a tap and you can chronometer the time it takes to fill in a certain volume, so you actually can have as well easily the measurements of flow for the taps. It's also necessary waterproof thermometer, could be a kitchen thermometer. And okay, for this case, I mentioned to have a chronographer or a mobile phone that will allow you to measure the time. In here, you can see on the left a pressure meter of up to 6 bars. It's good to have it for the measurements of pressure and head loss concerning energy, the energy dimension, and the metric tape. Okay, just to have a better visualization of the methodology, just show you some prints of the evaluation matrix. So first, as I mentioned before, you actually need to fill in on the matrix the current situation of the building. So the first thing to do is to actually fill in what is named the baseline scenario sheet, that it's a little bit of this first print above, where you actually introduce water and energy consumption data. So you can see a little bit here, part of the table for the water, for registering water consumption for a total of 1 year. And you'll have as well tables to fill in the technical data of fixtures and then any other water related equipment and systems existent in the building. So this could be different types of electric pumps, water pumps, circulation pumps. It can be the model and indications and characteristics of, for example, washing machines, etc. If it exists, if you have the information, of course. Then the second part will be on the different checklists, because each one of these dimension has a checklist in the matrix. So you go to each one of them and you fill in the current situation of the building. So to let you know, here is an example of the sheet of Water-Energy Nexus. So one criteria is this one where you can see N1.1.1. What is the international energy efficiency class of the pump? So this concerning the energy for water distribution. So this is the look of one criteria or one question. We always have indication of information on how you should fill in the matrix. I will not go into detail on these points at the moment, but you need to fill in this for all these questions, for all the dimensions. You'll answer the column current situation, and then put some justification on what you answered in this column, justification for the current situation. After doing that, you'll actually select maximum 2 to 3 infrastructural improvement measures per each of the dimensions. And then you introduce them on the checklist. So how do you do that? You select the measures and you look at the column situation after improvement measures, and you register the ideal situation here. So in this column, we'll put the answer has the building already, as if the building already had the improvement measure implemented. And you put some notes on the observations about the proposed improvement measures column just to justify why you select it. And why do you do this? You do this because actually you'll have another sheet here on the Excel file, the summary of results, where you can see actually all the scores and all the classifications for the building. So in here, what you can see for all three dimensions: water efficiency, water energy nexus, climate adaptation, and then the global final score. You can see the values in the first table in percentage, in the second in the classification. So, but you have the current situation values, and just next to them, the after improvement measures situation and the increase in score. So you can actually be playing, let's say, with the checklists and trying to select different sets of improvement measures that you think are adjusted to the building and that can improve the building's efficiency. And you can go here to these tables and you check how much is the increase in score for each of the dimensions and for each of the selected sets. So you can see in here, because the bigger the increase in score, the higher the increase in score, the higher the increase in efficiency in each of the dimensions. So it's the way to fill in and to apply the methodology and to help you, guide you to choose the best set of improvement measures for the building. Okay, this is a slide with lots of words, and it's actually on purpose, because as a result of this methodology, so actually this methodology was adapted, and it was possible because we had three partners that actually applied the methodology. So we had 2 pilot cases in Jordan, 2 pilot cases in Algeria, and 2 pilot cases in Morocco. One of them residential, and another one public building in each one of the countries. So the next speakers will give their results and their experience just after my talk. And what happened was they've applied the methodology and gave us feedback, and according to it, and according to the specific contexts and the different contexts, the methodology was actually adapted and adjusted. And while doing this, we made a compilation of all the recommended improvement measures for all the different dimensions. That made a compilation of which ones we would recommend, and this set of improvement measures with the details, and that's why you have here all the text. This actually it was introduced, the different improvement measures were introduced in the Green Guide, which is one of the deliverables of this activity that will be actually available soon at meetMED's website, where you can see all the information. So you have the title of the small explanation, short explanation of the measurement, and then you have extra detailed description and recommendations on the conditions to actually implement the measurement. And on top of that, and concerning the methodology, you then have the information of which themes or criteria the implementation of this specific improvement measure will actually improve. So in this case, the installation of local and decentralized licensed rainwater harvesting systems or grey water reuse systems will actually act on the dimension of water or water efficiency on the alternative water sources theme, as well as in the climate adaptation dimension on the water fit for purpose. So in here you have also this information on which dimensions and which themes and criteria it will, with each improvement measure, will act on. Another example of recommended measure for the water efficiency dimension is, for example, the introduction of flow restrictors with aerators on taps. And this is a simple one and a very not expensive measure that will actually help you limit water flow to maximum values that are recommended. Another example now for the Water-Energy Nexus dimension is the implementation of efficient water elevation or circulation pumps for adequate and stable pressure head loss values on the water network. Again, a description. This one is a smaller description, and then with the themes and criteria, it actually improves directly. Another one for the Water-Energy Nexus dimension would be to privilege gravity and renewable energy sources concerning water distribution instead of using active systems that use non-renewable energy. Two examples now for the climate adaptation dimension would be, for example, the introduction in outside gardens of blue infrastructures such as grain gardens, or the increase of permeable areas or the placement of permeable flooring outside. Now I've told you that this development of this methodology was actually possible because there was this implementation, this testing on 2 pilot buildings in Morocco, Jordan, and Algeria. I will go very quickly through this one as the next speaker will talk more specifically about this. So this is the public building in Jordan. So they've applied the methodology on a primary school. So I will not go into the details. I will just let you know the logic of the methodology. So it was the part of the baseline scenario that was made in the beginning was actually to see at which ones were the building characteristics and the technical characteristics related to water. So if the water is supplied by a public water supplier. In this case, in Jordan, it's stored in water tanks on the rooftop of the building. And what kind of systems, important systems related with water use that actually were implemented in the building. We look at the overall water and energy consumption, and we have for the current situation a global classification and a partial classification. So this is the current situation of the school. And then a set of improvement measures were defined with the main benefits identified as well, and the monitoring strategy also defined. By reapplying the methodology, so introducing the selected improvement measures on the Excel file, we had an increased global classification and new partial classifications, which were higher than, which were obviously higher than the ones for the current situation. So our colleague will soon, Marsley will soon explain better how the state of the situation is at the moment, but they are now implementing the improvement measures and will soon start monitoring. Okay, so I will talk to you about just as an to exemplify as well concerning actually one collaboration that we had within meetMED 2 with another activity that was activity 3.2.2. So reaching twinning agreements and implementing study tours for city officers that actually allowed us to give the opportunity to cities to implement the methodology, test and implement the methodology. So we've done, one of the cities that did this was Palmela. So in Portugal. So they've one of the buildings they've actually where they applied the methodology was this cultural center, Poceirão Cultural Center. So analyzed what were the building characteristics and the technical characteristics. In this case, the building uses are solely 8 toilets and 1 kitchen. It's a building that is used for cultural activities and presentations. And the relevant water uses equipment is solely the electric domestic water heater. So for the current situation, they've made the overall water and energy consumption and applied the methodology to a global classification of C of 47%, with 29% on the water efficiency dimension, 44% on the water energy nexus dimension, and 69% on the climate adaptation dimension. So they've selected and tested on the Excel file different sets of improvement measures. These were the ones that were selected. In the case of this collaboration with the Twinnings activity of meetMED 2, there's no implementation, actual implementation of the equipment or of the systems on the building, but just a test to see what could be the priorities if in the future there will be some rehabilitation of the building or of the equipments. So they've selected 5 improvement measures. So one of them, for example, was replacing the existing water meter per one new one that actually helps to record daily consumption data and has an alert system to better monitor the use of water and detect easily any leak, any water leak. They've decided as well on the replacement of tap, showers, and toilet flushers and other fixtures in bathrooms and the kitchens by a more efficient one with lower flow rates and with aerators to limit the flow, and the installation of a rainwater harvesting system, for example. So after reapplying the methodology, the building efficiency increased to a B, so a 60%, with improvement in partial classifications of plus 31% in the water efficiency and plus 8% on the water energy nexus. So who can apply the methodology? Actually, the methodology can be applied by any energy or water specialist, and as well by technical experts from energy and water agencies or from municipal, local, and regional authorities. I just would like to just let you know about this deliverable that will soon be available on the meetMED website. That's the Green Guide for Buildings Water Energy Nexus. This actually gives you contextualization of the water energy nexus the water energy nexus in the Mediterranean region. It explains the development and the functioning of the methodology. And an important part is the compilation of the most common and recommended water energy nexus improvement measures that were actually defined and compiled within this work. And then we'll have a section as well on the application of the methodology in the Mediterranean countries. So we'll have their pilot buildings from Jordan, Algeria, Morocco, and as well of Palmela. Just to let you know that from the compilation we've made, we actually had we actually identified 16 measures for water efficiency, 10 for water energy nexus, 3 for the climate adaptation dimension, and as well a set of 8 behavioral measures that were developed on the scope of this activity, as well to help develop the some material that was actually applied just some days ago in Algeria and in Jordan in some schools campaign. So we actually decided to include this material as well in the Green Guide, although there are behavioral measures, so it was not the specific focus of the methodology, but to let you know that you have all this information that can be useful and used in this, in the context of buildings and the water energy nexus and the efficiency of buildings, the increasing of the efficiency of buildings in this context. And that's all.
Thank you so much, Rita. So as I said in the chat, if you have any questions, you can put it there or you can ask in the end. And now I will give the floor to Mohammed Mosleh for the presentation of the pilot in Jordan.
Rita, for the rich presentation. I almost mentioned everything actually. So I would say it's a pleasure to be with you today. And before I begin, I'd like to thank and Rita for their support and collaboration through this activity. It's really appreciated, actually. Can you see it?
Yes.
Presentation, I'll walk you through Jordan's experience applying a water-energy nexus methodology in 2 pilot buildings. As Rita already mentioned, a school and a residential house, and share the insights we gained during this process. So as a part of this activity, we selected 2 pilot buildings that represent different types and usage patterns. The first is a single family house located in Swaleh in Amman. It has 2 floors, and we focus on the ground floor flat, as it contains 2 floors, as already mentioned. The house includes rooftop water tanks, a small garden, and it's equipped with common systems like a circulation pump, electric water heaters, and a laundry machine. The second is Iskandar Fayha Primary School in Madaba. It has 3 floors and hosts more than 700 students. The building was recently upgraded under another EU-funded project. It was called SOL. Double glazed windows, a solar PV system, and a solar water heater. So these 2 buildings were selected to reflect typical water and energy use patterns in Jordan. One from the residential sector and one from the public services, as mentioned before. The selection was made according to agreed criteria, including building type, data availability, accessibility, and I would say improvement potential in these buildings. This criteria, to be honest, made them ideal for applying the methodology and testing it under real operating conditions. So to fill out the tool, we needed a combination of field measurements, utility data, and desktop research. First, we collected 12 months of electricity and water bills for each building to establish the baseline. Then we measured flow rates at several points at the taps and showers using a simple method with a bucket and a watch. For the pressure, we used a manual pressure gauge to measure it at key points across the internal network. We also did a visual inspection of the fixtures and internal piping to identify leaks, inefficiencies, or damaged components. In addition, we recorded technical specs of the equipment, like water heaters, tanks, and pumps, mostly from the nameplates. Finally, for the climate adaptation part of the tool, we relied on desktop research, to be honest, from the national strategies mainly and official reports to identify risks like heat waves and water scarcity that could affect the building performance. So after collecting the data and doing the field checks, we established the baseline for both buildings. For the residential building, annual water consumption was around 315 cubic meters. Electricity use reached about 6,600 kilowatt hour per year, with nearly 2,300 kilowatt hours linked to water-related equipment, including the electric water heater, pump, and washing machine. The average flow rate at taps was around 7.5 liters per minute, and the pressure at the main entry point was measured at 0.3 megapascal with a head loss of about 0.1 megapascal. For the public school, water consumption was higher, about 510 cubic meters per year, and the electricity use reached 107 megawatts hour. The water-related systems consumes roughly 150 kilowatts hour per month. Flow rates varied in school by floor from 7.5 liters per minute on the ground floor to only 2 liters per minute on the second floor. The static pressure dropped from 0.1 megapascal at the entry to just 0.05 megapascal on the upper level. So these results confirmed several inefficiencies, I would say, especially in water pressure and distribution, and gave us a solid reference for selecting the right measures. So based on the assessment and the tools results, we selected and implemented a set of tailored measures in the public and the residential buildings. For the public school, we started by installing a booster pump, which solved the low pressure issue in the upper floors, as we already mentioned, especially in the second floor classrooms. We also set up a drip irrigation system with an automatic timer to replace the manual watering. This improved efficiency and reduced water waste in the garden area. In parallel, we conducted maintenance on the internal water network, repaired some minor leaks, I would say, and added tap aerators on several fixtures to reduce flow without affecting the performance. Finally, we installed a rainwater harvesting system, including a 10 cubic meter tank, divided into 2 tanks, to be honest, a filtration unit and a pump to supply non-potable water, mainly for the irrigation. All these measures, as you can see, already been implemented at the school, and you can see a few photos here for the actual systems in place. So in the residential building, we selected three practical measures tailored to the size and the needs of the household. First, we installed a solar domestic water heater. Its capacity is about 200 liters. Yeah, I guess it's a 200-liter system to replace the electrical heater and reduce the electricity consumption related to water use. Second, we introduced a drip irrigation system with a simple timer, as we did already in the public school. This helped improve water management for the small garden area and reduce manual watering. Finally, we added tap aerators also to the kitchen and bathroom taps. This was low-cost measure that reduced flow rates without compromising the user comfort. And I guess it should be noted here that these measures were selected based on feasibility, cost effectiveness, and their expected contribution to improving the building's water energy performance. So here's some results showing before and after in school. After implementing the selected measure, we updated the tool, of course, to reflect the improvements. The results showed clear progress in both buildings. For the residential building, the global, let's go, okay. For the residential building, the global score improved from 43 to 52. Okay, okay, here's the residential. I guess I mixed them up. I'm not sure if it's turning. Check. Okay, no. I guess that's right. So sorry for this.
Yes, now we are seeing the PowerPoint.
Yeah, sure. Sorry for this. Just I wanted to make sure that we are talking. I'm saying the right figures. So for again for the public school, where is it? Can you see it or not?
No, right now we are not seeing the PowerPoint.
Okay, just give me a minute. Can I stop share and just do again?
Yes, and share again. Yeah, of course, of course.
Yeah, please. Sorry for this.
It's okay.
Laptop issues. Okay. So can you see it now?
Not yet. I don't know if it's loading. Okay.
Okay, what
yes,
about now?
Yeah, now we are seeing.
Okay. So we were here, yes?
Exactly.
Okay, so again, for the public school, the overall score went from 41 to 56%, also improving from D to C. Water efficiency saw a major increase here from just 15% to over 51% due to the irrigation system, leak repairs, and aerators that we mentioned already. The Water-Energy Nexus dimension improved from 47 to 52%. And even the climate adaptation score saw a small rise here due to the better rainwater management. Okay, so for the residential, the global score improved from 43 to 52%, which moved it from D to C. The water efficiency increased from 34 to 48%, and the Water-Energy Nexus dimension rose from 33 to 46%. The climate adaptation score here remained the same as no related measures were implemented. So after implementing the selected measures, we updated the tool and we updated the tool to, let's say, to reflect these improvements. And the results actually, as you can see, showed clear progress in both buildings. So talking about the economic and benefits estimated in both buildings. I still have the same issue. Just doesn't move. Sorry, my laptop needs some.
It's okay if you think it's good to stop sharing and start sharing again, if you prefer. I don't know.
Okay.
It can help.
Yeah, sure. Can you see it now?
Not yet, but probably still loading.
Old laptops.
It's normal. We have the facility to do webinars, but technical problems are always present.
Okay. Thank you for your patience.
Musleh, maybe you can send it to Maria and she can share it instead.
Yes, if you prefer, I can do that.
Yeah, sure.
Meanwhile,
I
we
don't
can
know.
send it to Maria, yes.
But now
Is
we can
it
see it.
clear now? You can see
Now
it
we
now?
can see.
Yes, I can
Yeah,
see it.
yeah.
Economic and benefits
Okay,
estimated.
perfect.
Yes.
Thank you. It's working again. Okay. So we're talking that based on the tools calculations and our estimates, we were able to quantify the savings and the expected payback period for each measures. So in the residential building, the solar water heater is expected to save around 1,300 kilowatts hour per year, with a cost saving of about 160 GOD and a payback period of around 7.5 years, which is an intermediate payback period. The drip irrigation system is estimated to save about 54 cubic meters of water per year with a payback of roughly 3 years. Is it clear? Yes, I guess. Okay. And the tab aerators through a low-cost measure still save around 13 cubic meters per year with a very short payback of less than a year, as you can see, 0.85 years. So in the public school, the drip irrigation system and the network maintenance with aerators led to combined savings of over 170 cubic meters per year, with a payback ranging from 1 to 5 years. The rainwater harvesting system, while beneficial, to be honest, has a longer payback, about 24 years, but it surely adds value in terms of resilience and reuse. Overall, these numbers helped us build a clear picture, I would say, of the economic and environmental benefits, and strengthened the case of wider adoption. So last but not least, I would say that last week we conducted an awareness campaign at Sampayha Primary School as part of this activity. The campaign focused on basic water and energy conservation practices, as well as introducing the Water-Energy Nexus concept in a simplified way for primary students. We reached more than 500 students in addition to teachers and staff. And I'm glad to share with you that we also received a very good positive feedback from the administration and the Directorate of Education in Madaba, which expressed strong interest in expanding this kind of initiative in the near future. So, and here, please allow me to thank Asma for her great support and collaboration, and for sure our colleagues in EWA for their huge efforts preparing the awareness materials. Their efforts actually made it accessible and fun, I would say, and very impactful. Yes. And also, I would say that this experience really highlighted the importance of pairing technical interventions with clear communication and education, especially when working in schools. So finally, going to the challenges and the opportunities, I would say that throughout this activity, we encountered several challenges, but also identified clear opportunities for future scaling and improvement. Firstly, one of the main challenges was the need to adapt the tool to our local context, as Rita already mentioned. This required several rounds of coordination and technical modifications to align with low data as structured, let's say, how it is already structured and collected in Jordan. While necessary, this process did affect the overall timeline. Then, in the residential pilot, we faced some difficulty accessing all areas of the house during the site visits, which made some measurements harder to complete. This is maybe due to our traditions, but in parallel, we also experienced delays at the school, mostly due to the official communication with the Directorate of Education and Madaba to get the unsecure the permissions to install the measures we already mentioned. So I would say there's maybe one more challenge related to the procurement and installation, mainly related to the tendering process, which took longer than expected. But thank God we finally could manage everything in time. But on the other hand, the experience also brought valuable opportunities, as this tool proved to be both flexible and practical, and helped guide us from assessment to implementation. It also created strong awareness among users, especially in the school, and showed high potential for replication, particularly in public buildings and across municipalities. So lastly, we looking ahead, as we believe this tool could be developed into simple desktop or cloud-based application that would make it easier for local institutions to carry out similar assessment and to plan and implement energy vehicle assessment more effectively. Thank you so much. And I'm sorry again for the technical issues. Thank you. And if you have any question, I'm here.
Thank you so much, Mohammed. I think it was a very interesting presentation. It's very interesting to hear the ones that really experienced the implementation to share the main challenges and opportunities in practice of this methodology. So thank you very much. And with this, I'm going to pass the floor to Fairuz Hamli to share APRU experience. Thank you.
Okay. Hello, everyone. Hope we're all doing fine. I'm so honored to where we get in the stage. You, Maria, Rita, Musleh, the AMI team, Esma for the communication. I mean, it took a lot of work, hours and years for the technical part and for communication campaign with the EWA. And I'm so happy to share with you some insights for from the 2 pilot buildings that where we implemented the methodology led by ADENE. But before we dive into these 2 pilot buildings, I prefer to start with highlighting the Algerian context and why this thematic water-energy nexus is important for us. Today, Algeria faces increasing pressure on water resources due to climate change and population growth, also for the energy sector, which consumes more than 46% from the final energy consumption for the building sector, also consumes significant water. Conversely, the water sector is highly energy intensive for pumping, treatment, and distribution. And to be honest, for the challenges we faced before applying the methodology led by the ADENE, it was a lot of lack of awareness and behavioral among users regarding efficient water and energy use, especially in schools. Just to mention that this activity was with other activities under the frame of meetMED 2. We worked a lot about public buildings with priority tool, energy audits, and we had the chance to ask questions about Nexus Water Energy if we have that much of awareness and behavioral among the users. Also, for the markets, the Algerian market, it was limited availability of high performance equipment and also due to the awareness of the users. The monitoring difficulties due to absence of real-time data and the buildings, whether it's schools, a residential building or public building. Also, one of the main challenges we encountered during our work, it was the fragmented institutional coordination between water and energy efficiency programs. It's also common that the energy sector work about the energy efficiency, energy transition, the water sector work about water, but thanks for the methodology led by ADENE and exchanging experience with Jordan, Morocco, other countries to highlight the importance of Nexus Water Energy. First of all, we set into this projects some objectives like application the Nexus Water Energy approach to foster cross-sectoral synergy and renovation efforts with other actors, also to reduce water and energy consumption using integration and efficient systems, promotion educational engagement, and build culture of sustainability in schools and other public buildings, because I believe that this kind of project is not only about the technical part, but also about building the ownership and responsibility among the users, and also to contribute to our climate action goals through tangible improvements in resource efficiency. Well, I will start with the public building, which is school in Boumerdès, Algeria. Its land area about 1,200 meters. It's old school with double brick walls, and conversely to the Jordanian pilot building, our pilot building, it was poor with energy efficiency measurements. So we started with the water efficiency measurements to the school, and we ended up with the energy, and it was an opportunity actually, because when we started work, it was a renovation project about this building, and we had a chance to talk with the company and with the municipality about how important to also integrate these measurements, not only for the water energy nexus led by the methodology, but also by improving the double glazing, the insulation, also to lead communication campaign all the time to ensure the long-term pilot building sustainability. Baseline scenario of this school, overall water consumption, it was 37.3 cubic meters per month, and for the overall energy consumption was 2,294 kilowatt hour per month. It's kind of small school, but it's important for the area where we analyze it, because it's the only school in that area, in a small town in Boumerdès. So it was a very important school to the municipality. For the methodology highlights, global classification, it was 10.1% F. It's shown how poor energy and water efficiency in that school. For the partial classification, water efficiency, it was 16.3% E, water energy nexus 3.7% F, and for the climate adaptation, it was 10% F. After the measurements selected for the school, and just to highlight that it was a lot of measurements selected for the methodology with several impacts, but we try to choose the impactful measurements, the low cost, high impact measurements available according to the activity, but we kept like long-term action plan for the next month with municipalities. So the methodology helped us really to get into really energy efficiency measurements to the school, with highlighting the same measurements led in the methodology. For water efficiency dimension, we selected the installation of low flow fixtures, 2 types of them. Also for the climate adaptation dimension, we choose to implement more gardens to the school. It wasn't only about having gardens, but it was educational program and more ensuring the responsibility, the common responsibility between all the users of the school. For the water energy nexus dimension, we have selected the solar powered water heating for the school. It wasn't also not only equipment installed in the roof, but something that can impact all the educational, essential for the children, yes. The proposed solution for each dimension, as I already mentioned, it's a low flow, solar water heater, and more gardens. This is real photos of the school, where we installed the solar water heater, 2 types of low flow fixtures. We have selected one temporizer with less than 10 seconds to raise an awareness among the users that the water has its time. It's not for all the time. And the other one, it was with infrarouge, when we can use water only when we need it. So it was really a selective equipment to not only for the technical part, but also for the raising awareness. For summary for the results, we as it's shown that the building improved and moved from very poor efficient water energy to amelioration and the global classification. We have observed a really tangible improvement with 18.9% F, for water efficiency plus 33.2%, for water energy nexus plus 23.6%. And beyond the technical improvements, as I already said, we had the opportunity among the pupils and the staff and teachers. We had this opportunity of the Green Day in collaboration of RECRE and ESMA and ADENE and EWA to have this Green Day not only for the teachers and staff and pupils, but also in presence of all the municipality stakeholders, the direction of energy, direction of education, different actors with us, like the National Agency of Water, National Agency of Recycling, to have all these actors of this thematic for water energy efficiency. And we had the opportunity actually to explain our application of the methodology led by ADENE, and also to raise an awareness and have this improvement, behavioral improvement by interactive action and sessions with all the users. And to be honest, the time after the Green Day, we had very positive feedback, as Muslah experienced also. It was like more demand for this type of implementation. We had signed with other municipality to have other implementation, like this school, Tarfi Milud. We have been called for other Green Days, raising awareness for water nexus energy. For the second pilot building, it was a private building built in 2012 with 3 floors, also double brick walls, single glazing. It wasn't that much energy efficiency. We haven't that much energy efficiency measurements, but as I already said, that it was the opportunity to start work from the beginning and see the impactful, of the methodology. Overall water consumption, it was 16 cubic meters per month. For overall energy consumption, it was 135 kilowatt hour per month. And partial energy consumption for water-related equipment, 35 kilowatt hour per month. The relevant equipment related with water use, it was the laundry, the pumping, and several equipment that you can after have it in the guidebook. The methodology highlights that we had the global classification 18.5% E. For partial classification for water efficiency, it was 23.1% E. Water energy nexus 12.2% F. Climate adaptation, it was 20 E. For the proposed solution for each dimension, as I already mentioned, that the selected measurements, it was only according to the timeline of the activity and how low cost, high impact measurements, but also we had long-term action plan for the improvement of the measurements. We have installed low flow fixtures in kitchens and bathrooms, switched to energy efficiency appliances like washing machine and dishwasher. And for the climate adaptation, it was like planting drought species in the gardens. And we had improvements with plus 15.6% for water efficiency and plus 8.2% for water energy nexus and plus 14.3% for climate adaptation. The benefits of the application of the methodology and all the work done during this month, it was not to bother you with technical details, but I will just describe briefly with some sentence. We had observed water savings in the 2 pilot buildings, noticeable energy savings in school lighting and HVAC usage post-awareness. The methodology helped us to raise an awareness among the users, increase knowledge among the children, teachers, also the municipality, and enhance replicability. So these 2 models can help us or serve as beneficial pilot buildings for future implementation at national level. And now with the APRO team, we're preparing to have more pilot buildings implemented by this methodology. For the opportunities after this work, our problem or our issue and our challenge in this type of projects, it was from the beginning how to have all the actors related to energy and water thematic. So it was opportunity to have all these actors having trainings for the municipalities by explaining the real impact through this kind of the projects, not only for the technical part, but by ameliorating the national action plan among the municipalities, explaining them how more jobs in this kind of projects can help not only the technical part, but our economy, more collaboration of the national institution, like the National Agency for Water and Recycling, and we approved the National Agency for Energy. Also, we had collected more engagement from the civil society. We have been called from an association, which is named Torba, and she offered like 1 year of education program for the students about the climate adaptation, having more climate or more planting that helps the water efficiency and savings. So it was very beneficial work with the activity 3.13 and with all the team. And I'm so honored that we get into the stage and have the chance to present it to all the public audience. And thank you.
Thank you so much, Fairuz. It's really interesting to see the similarities and the difference between 2 countries that applied the methodology. So we know it's not similar because it has different adaptations for your different contexts, and each context has its own difficulties. So it's very interesting to hear both of your experience, and thank you so much. So with this, I think we can now start the questions. I see that we already have one in the chat. So Rita, if you want to give us an answer to this question regarding where we can download the Excel sheet, or if we can share it by now.
First of all, thank you very much for the question. At this moment, we actually cannot share the Excel file, as it was the methodology was developed within meetMED 2. But it's important to have your feedback and your interest, and if maybe you can send us an email. I can to let you know who do you represent and for where you're from, because it's important to have this feedback and interest on the methodology, so that we can actually evaluate the continuity of the development of the methodology within the next phase of project meetMED. So I will put my own email in the chat. And if you can then send us an email and let us know that you're interested, and this will be taken into consideration for the next phase of meetMED 2. Thank you.
Thank you, Rita. So I ask if someone has more questions. If you want, you can raise your hand. It's easier. I think your presentations were all very clear because we don't see any questions. Of course, as Rita said, you can also use our contacts if something come up, and you can put your questions by email if you prefer. Okay, so if we don't have any questions, or if you prefer to put it in the other way, I think that now I'm going to give the floor to Charles from EWA to give us our closing remarks. Thank you.
Yes, thank you, Maria. Thank you, everybody, for giving me this opportunity to conclude this webinar. And especially, I'm very contented of the presentations done. The effort by ADENE in their exercise to build up a system where and this inextricable link between energy and water can be put into numbers. And of course, the participation of Jordan and Algeria, where I see that the results actually work. Especially, I was contented in the work done at the school level and the teacher level. But apart from that, obviously, I want to make just a small reference to even to what Rita said, the link that exists between the energy and water, the energy and water nexus. The concept that is increasing attention across industries and government and NGOs. I think we as southern member states, let's call it southern Mediterranean member states, we all appreciate this link because we know the importance of water, and there obviously the link it has to energy. So it's important for us. I need go into much detail. I think Rita explained very well the link, the generation of electricity, even the how do I say, the production of fuels that requires water. So the link between energy and water is there, and we need to continue bring it to attention to the public and in our policies. As correctly also stated by Rita, the Mediterranean region, we suffer droughts, we suffer increased urbanization and demand for energy and water. And so it is important that in this increasing awareness of climate change and its effects, we again tie energy and water and bring them to the forefront in our policies. So what is the way forward? What is the way forward? First of all, we need to embrace efficiency. Efficiency in both resources, because as I said, they tie together and they can change dramatically the way we operate. Renewable energy is very important, like wind and solar, and obviously their impact will also be on obviously our water footprint, especially us, for example, on the islands of Malta and Gozo, where we do a lot of desalination of water, which I think is becoming also very, very an important operation in the Mediterranean states. Second, we need to do integrated planning and policy making where these two resources are put at par, where we realize that energy and water resources are tied together. And so when we think of one resource, we have to think of the other. Finally, public engagement. We've seen it, thank God, in Jordan and Algeria, and obviously education. Conservation is not just a government responsibility, it is a social responsibility. So the way to conclude is what I said. So the next time we switch the light on, we not only think of switching the light, but we think that somehow we're affecting water also. And the other way around, when we open the water tap, somehow we're affecting the generation of electricity. Thank you very much. Thank you very much for everyone. But then especially, I know you do a lot of work, the southern member states. Thank you very much, everybody.
Thank you so much, Charles. Always very interesting to hear your final thoughts about this scene. And with this, if we don't, now I'm seeing only here the chat, but I don't think that we have doubts. Thank you, Rita, for sharing your contact. So with this, I just wanted to thank again all the speakers, Charles, Mohammed, Fairuz, and Rita, for your availability and for sharing your great experience. And also thanking very much Ajma for all the efforts for the communication and to dissemination this webinar. And thank you to all the participants for availability. Wait, I think I saw just a question on the chat, so we're going to answer it. Okay. I don't know if Rita or Mohammed, if you want to answer this question. I don't know which of you prefer.
I actually don't understand very well.
Me neither. Ahmed, can you please be more specific?
Yeah. You can write it here. Because I don't think you can turn on the mic, right? I think it's not possible.
I think we can give him we can give him the opportunity. What is his name? Ahmed.
Yes.
Just a second.
Good.
Yes, I can open his mic.
Okay, thank you. I
Ahmed,
think it's easier.
I will allow your mic. Would you please, Mr. Ahmed Aid? Mr. Ahmed Aid, now you are mic and the camera allowed. If you need to open your mic and open your camera and ask your questions for the speakers. Mr. Ahmed Aid.
Okay, I don't know.
The first thing for the manager project or project manager to see on the audit plan. Maybe he's asking about the first criteria to be observed by the project manager within the audit plan. If I could elaborate, because he sounds to be an Arabic speaker.
I would maybe, because I cannot understand well the question, I would maybe ask if you could send an email, the question by email, if it's not possible for you to talk now to explain. I think it would be easier.
Yeah, I think it's easier for us to better understand the question.
Yeah, yes, I can add some info if I understand it well. Maybe he's asking about the audits in the pilot buildings. How we can start with, but to answer your question, if I were right, you should start looking at the methodology which Rita already shared with us. And if you look at it deeply, you will see there are like 4 tabs that needs to be filled out. Each tab requires a lot of data. As I already mentioned in my presentation, there is some cells require desktop research. Some of it require some measurements and site visits, and others would require also visual inspection. So according to all these data that should be filled out, you can create your plan. If I get you in the right way.
Thank you, Mohammed. I don't know if it's clear now, but also, as Rita said, if you have any more question or if you don't feel that you are already clarified, you can send us an email to better explain your question, and we'll get to you. So if we don't have any more questions now, I think we don't. Okay. So as I was saying, I was just thanking all the speakers to be here for the availability. Also thanking Asma for all the efforts and the work carried out. And also thanking all of you that that were participating in this webinar and stayed here until the end. Thank you very much. And I hope that it was a very fruitful webinar and an interesting theme for you to learn more about. So thank you, everyone. And I wish a very good day, rest of day for all of you. Thank you.
Thank you very much.
Thank you so much.
Thanks, everyone. Have a good day.
Have a good day.
Bye-bye.